Hello, everyone. Welcome to Module 4, which we're going to talk about functional testing. So the learning objectives for this module is you should understand the rationale for selecting systematic test cases over the random selection of test cases. The second one is you should understand why we use functional test selection as a baseline technique, which means the basic technique that you can adopt to most of the test activities. And the last one is you should be able to distinguish functional testing from other systematic testing techniques. Okay, so let's get into the concept of this module. First, what is functional testing? Functional testing is the process that we derive the test cases from the program specifications. So the word functions or functional refers to the specification of the program. What are the functions that the program can do? And we refer this information because it is used in the test case design. Okay. This functional testing is also known as two additional names. First, it can be called specification-based testing because it is based on the specs. And the second one, it is called black box testing, which means you test a software as a black box. You don't see the code and you don't need to see the code as well. So functional spec that we discuss here means the description of the intended program behavior. So it must list what the program should do and what is the behaviors of the program. So by doing functional testing, we would like to find what are the test cases that we should use to exercise the program. So we only think about the test cases based on the program specification. And the functional testing, we have four following characteristics. Okay, so the first one is the functions or the features of the software are tested by feeding the input and examining the output. Okay, this is important. We can only give the input to the program and we can only check the output of the program. The second one is that functional test ensures that the requirements are properly satisfied by the application. So we check with the requirements. So this is a verification activity. Okay. The third one is, since it is a black box testing, we don't care or we do not concern about how processing occurs, but we only check the result of the processing. And this kind of functional test actually simulate the actual system usage because it does not make any assumption about the implementation or the architecture of the software. So when I say black box testing, it means you have this software as a black box. You don't see what's inside, you don't know how it's implemented, and you don't know the logic inside. What we can do is that we can only select the input to be given to the program, and we can only see the output that comes out of the program. So by doing black box testing, we don't care about the internal logic of the program, how it is implemented, but we know from the spec that it must give this kind of output given this input. That is the two main things that we're going to use for functional testing. So mostly functional tests, when we put back into the V model, it would go around these two steps. When you do system tests and when you do user acceptance tests, we mostly do functional testing, which means you only check by giving the input and then you check the output. And you don't see what is implemented inside. In the system test, the development team will be the one that perform the test, while in the user acceptance test, the user will be the one that do this kind of test. So what are the steps in the functional testing? The steps are as follows. First, we must identify the functions of the software. Okay, so we must know what the software can do what is expected for them to perform. And then we create the input based on those functional specifications. So you must select some set of inputs, okay? And these tests of input will become our test cases. After that, you feed the input into the program, and then you determine the output, and then you check with the specification whether that output is correct or not. Oh, sorry. This one means we determine the expected output. Okay, so based on the spec, if we give this input, what are the expected output? So for example, if we have the method sum, okay, which accept two number, you know that if you give A and B with the value of 1 and 1, the expected output should be 2. If we give 1 and 2, the expected output should be 3. Okay, so these are the outputs based on the function specification. And then you execute the test case, and then you compare the actual output with the expected output that we already defined before. So if you already tested the sum method, and then you found that the actual value is 2 when you give 1 and 1. So this test case is okay. But in this case, if you get 4, 4 is not equal to 3. So this test case is failing. And then you need to check what's wrong with the program. Okay, so these are the very basic concept of functional testing. You understand the spec, you create the inputs, you create the expected output, you execute the test case, and then you compare the actual output with the expected output. So the way that we select input can be different. You can systematically select the input, or you can just rely on random sampling of the input. So in this slide, I want to discuss a bit the difference between systematic and random testing. Starting with the random test. So if we do random selection of the test case, you can select the input uniformly, which means you can select the input from any value of potential inputs by having equal priority. You can select every single value and then you skip by 10, and then you select another value and then you skip by 10, for example. This kind of random or uniform sampling can help in some cases that you can avoid some of the what's called designer's bias, which means if you ask the programmers or the program designer to find some test input, they might select some values that they know it will make the program pass because they are the one that creating the program. So we have this kind of bias in our mind that we would select the test input that usually will pass the test. So if you do random or uniform selection of the test cases, you might be able to avoid such bias. This way, we treat all the inputs with equal value or equal priority. We don't give any special priority to any of the special inputs. Okay, so random testing is one way that you can choose the test cases. However, we can also do systematic testing, which means we try to select the inputs that are especially valuable. So instead of having the value, let's say if you have this lots of values spanning from -10 to 10, sorry, the uniform sampling, you might pick each one of them at the equal range between each value. Okay, so this is uniform sampling. But if we do systematic sampling, we might select some value that are having high chance of failure. So we might select 0, and we might also select some value close to that value, which means we might select value of 1 and -1 as well. So systematic testing, we select the input based on their value. Which one has more potential to find bugs, we will pick them. Okay, so usually the way that we do is that we will find the classes first, and then we will be choosing the representative of the classes, and then we use that value to be the test cases. We're going to discuss in the few more module after this, how would we divide the classes and how would we select the representatives, okay? But in the end, functional test is systematic testing. So we would not randomly select the values, but we will have the way that we will systematically select the value that are mostly valuable for our test. So to give you some motivation on why not using random testing, if we go back to the example in the first module, we have the method sum. It accepts A and B. So if you try to find all the possible inputs, that would mean we will get 2 to the power of 64, which is a really huge number of test cases to be selected from. However, we have some limited budgets and some tight schedules, right? We cannot try every single value. The value that we get from this can take us something 500 million years, right? So that is too long to try every single value. So there must be some test cases that are better than the others. We focus only on that part, and that would save us time while still preserving the quality of the test. Moreover, the distribution of faults are also non-uniform. So we must pay attention to some specific value that might trigger the faults the most. So let's say if you have a program that try to implement this quadratic equation of computing the roots, okay? If you look at this formula and think about it, so let's pause the video for a minute and think about what should be the input value that you would choose. Just one value that you think is the best to trigger the fault in the program. Okay, so have you got a number? One of the most obvious number to choose from here is the value of A, right? We see that the whole formula is divided by 2A. So the first number that we should try is what happens if your A is 0? And this will be divided by 0. Is it going to make any errors or any failures? The other things that you can try is you try to make this value to become positive or to become negative, and then you see how the program behaves. Is it possible to handle the square root of negative numbers? What should be the result? Okay, so you can see that if we don't select these values and we just keep going with something of A equals 1, 2, 3, 4, 5, 6, 7, and so on, it doesn't help that much because the fault should be somewhere around this 0 value. Even if you try some negative number, -1, -2, -3, so on and so on, it might still be the same. But selecting 0 is a key selection here. So the task of doing functional testing is similar to finding a needle in a haystack, right? So if you have a needle, it was put somewhere in the haystack. We need to find from this whole big location or the whole big input space that we have and try to pinpoint which part that we should focus on so that we can find the needle faster. If you search the whole thing, it might take you ages. But if you know somehow that the needle must supposed to be somewhere close to the left or close to the right of the haystack, that would save you time. Okay, so this is a metaphor to show that we cannot just do uniform sampling of the test cases. Okay, so by doing functional testing using systematic tests, we would need to chop the input space that we have into several partitions. Okay, so this is called partitions. This is another partitions. There can be a lot of partitions, and some of the partitions might contain some faults, right? So when we divide the input value into partitions, so let's say this might represent the number from -100 to 100. And the value has some special priority here, that the value which are marked in red boxes has more potential to trigger the fault and create software failures. So we would use this systematic partitioning to create group of input values, and then we select some representative from that group. Let's say I might pick this one, I might pick this one, I might pick this one, this one, this one, this one as a test cases, and then we maximize our chance of finding the faults and the failures. So as I already told you before, that functional test relies on the specification. So we must first understand what is the specification of the program and how does it work? How does the program follow such specification? So for the example that I showed you before, if we have the root programs, we will know that the division might be problematic when you are dividing by 0. And then by testing such specific cases, we should also test the boundaries of each category as well. So you first divide the input into multiple categories or classes. We test the value from each of the classes, and then we also test the value that are between the boundaries. So let's go back a bit to your introduction to software engineering classes. We discussed 2 testing techniques. The first one is equivalent class partitioning, where we divide the input into multiple classes. Each value in the same class will have the same priority of finding bugs, so you can select any representatives. And the second one is called boundary value analysis, which improve upon the equivalent class partitioning by selecting the value that are close to the boundaries as well. Okay, that maximizes the chances that you would reveal the faults in the program. So why do we do functional tests? Functional test is very basic, and it can be used as a baseline technique for designing test cases. So if you can't think of any other techniques, we come back to functional tests. The reason is because first, functional testing is timely, which means you can use it based on the spec, and you can even check before the code is written because you are checking the spec, right? So you can read the specification and then you make sure that everything is clear. So even before we write the code, we can already starting doing testing. The second one is functional testing is effective because we can divide the input into classes, and we might find some missing logic that the program doesn't take into account some of the input. Some of the input classes. The third benefit is that it is widely applicable. So you can apply the concept of functional test into any test level. You can use it for unit tests, you can use it for integration tests, you can use it for system tests, and you can use it for user acceptance tests. The last one is the functional testing is economical because it doesn't takes too much time and understanding. You just need to understand the software specification compared to other techniques, which might rely on the code, it might rely on the logic inside the code, so on and so on. Okay, so it's a lightweight method that you can apply mostly at any level of testing.